All right, I want to share with you some detailed thoughts on the actual process of doing prototyping scatter plots and initial prototyping of trading systems. And there's a number of ways to go about this. And for stock systems, it's probably more appropriate to do automated back tests because stocks are so uh, stocks you need a lot more data than you can do here. Okay, so what I've done, and this is the template. I'll have to build it out quite a long way, but I'm showing you the concept here. Is I've got a number of trades that I took on this particular day, some comments on the trades, screen capture. I saved it to screencast. You can use any one of the cloud things. It's just good to have them permanently. I've got an R value, so this is how big the distance to the stop was. MFE is maximum favorable excursion. So this was the winner at its biggest point. So we have a 2.06 winner, a 1.06 winner, a 2.76 winner, and a 2.36 winner. Come in, Daniel. So my point here is what we're trying to do is we're trying to optimize a system to give us the best risk-adjusted returns. Now, we're not necessarily trying to make the most money. That's an amateur error. That's an amateur thinking. What we're trying to do is get a reasonable amount of money with the lowest drawdowns. Because what amateurs look for is, I can make $1 million, but if you make 100% with giant equity swings, it's gonna send you crazy. So what professionals tend to prefer is steady, smooth, compounding, everyday stacking paper. And you've got to remember that our goals for this system are profitable 4 out of 5 trading days. This is a system for income. It's not going to be acceptable to have a multiple year drawdown like, say, trend following systems can have. Just not acceptable. So I've got maximum favorable excursion. I've tested to keep myself honest, I'm testing parabolic SAR, which is a sort of a near enough is good enough kind of trailing stop methodology. And what it does is it gets tighter the longer the stop goes on. So it's you can do complicated and correct trailing stops, but parabolic SAR is like a good back testing, prototyping sort of thing, and it's like a near enough is good enough situation. Now, the other thing I'm testing is parabolic SAR, but moving the stop to break even once it hits 1R. Now, what measuring maximum favorable excursion lets us do is we can very easily produce a number of results. Like if this got to 2.06, it would have been a 1 if it was a 1R target, a 1.5 if it was a 1.5R target, and a 2 if it was a 2R target. This one would have been a 1 if it was a 1R target, a -1 if it was a 1.5R target, and a -1 if it was a 2R target. So what I can do is add up the trades for the day, the winning trades for the day, and say, okay, if we were using 1R targets, we would have made 4R. If we're using a 1.1R target, we would have made 2.3R. We unluckily got a 1.06R winner that wouldn't have hit 1.1, and that would have been a 1R loser. That would have been hurtful, but just unlucky. It's a small data sample size. 1.5R target would have given us 3.5. A 2R target would have given us 5R, so it would have given us slightly more R, but drawdown along the way. Now, parabolic SAR, which is the default kind of trailing stop methodology, would have given us 4.28, so it would have given us slightly better. Parabolic SAR, while moving stop to break even, would have given us only 2.78R. So the lesson here is really quite insightful, is that any sort of moving stop to break even is by definition, and I mean by definition, inefficient. With trend following systems, you have to do it because it's emotionally crippling watching a winner turn into a loser. But it, by definition, reduces some of your gains. Now, what I did here is I went and filled out this big table of after bar 2, bar 3, bar 4, bar 5, where were we in terms of R? Like how many R did we make? And what I did is I built a scatter plot for that, which I've got in this other sheet. Now, let me show you exactly how to do that. So it's kind of clunky, but you have to copy all these down into one big column and just put zeros, 1, 2. So I took all this data, copied it down to there. There's probably a way to write a formula and do that, but my spreadsheets aren't that good. Someone better than me. Now, what you do is, so you select all the data like this and go insert chart. Okay, now you can customize it, put titles and axis, but where the real customization going is in series. So we want to put a trend line, and it default assumes that it's a linear regression line. Make that a bit big so you can see it, and I'll make the color a bit different so you can see it. Now we want to show R squared, and we want to go to where it says label, instead of custom, go use equation. So this gives us our R squared value of 0.188. So this is our scatter plot. I've already done it up here. So this is bars, this is the number of bars, and this is the profit in R. So you can see that for just these 5 trades, we've got a shitload of data. You know, sometimes they've lost money, sometimes they've gone up and gone down, but what we have is a line that goes from bottom left to top right. So which is by definition a statistical definition of a positive correlation. So if we just randomly got in this trade at a random point and then random got out at another point, we would be on average making money. So what this is telling us is that the entry technique isolated, like a scientist isolating just the entry technique as your trading system, on this day of data anyway, we've got quite a lot of data, and it's showing unequivocally we have a weak positive correlation. Now, one of the things about the stock market and other markets is that you never get perfect correlations, because markets are really quite well arbitraged. All your edges are going to be weak edges. There are no magic tricks in the markets. If there were, some billionaire would have already figured them out and arbitraged them away. So we're dealing with weak edges. So your scatter plots are always going to look like this. Okay, so let's go back and review what we found today. Is what we're looking for, if our system is valid, is we're looking for we're not looking for, if I got, say, a 1.5R target was great but all the others sucked, if I got the parabolic SAR was great and the others sucked, I would be thinking I'm curve fitting. And if you ever see that in your systems, you're almost certainly curve fitting. Now, what we're looking for is a forest of decent numbers. And that's what we've got here. We've got, we've got a whole heap of decent numbers, right? I don't know why it's doing that. Okay, so I won't calculate expectancy for all these different things, but you can see that all of these numbers are perfectly acceptable, just some are better than others. So what is our task as trading system designers? What we're looking for here is to get the best risk-adjusted return. So we're not going for the most money. Optimizing for parameters is generally a mistake in trading systems. You don't want to go for the absolute best tippy top, and why not? Is because your future results aren't going to look exactly like your past results, and the future and the past aren't exactly the same. So what you're looking for is a reasonable best guess of a middling to good result. So you probably don't want to take your best one, especially if it's extreme parameters. You want to take the result where your parameters are mostly good. So I wouldn't take the 2R target here, even if the results were substantially better. Yeah. So anyway, that's all for today. I'll be continuing on with this. As we get more data, you'll see it. The system's really coming into shape well. So we're going to develop a giant big ass back test. And I know it goes slowly at the start, but it gets quicker. So pay attention.